Okay. Alright. So as promised, today we are going to discuss some question regarding projectile. Okay. So before we start discussing, let's recap this equation of constant acceleration. So the first equation talks about the interrelation between T up. Okay. Jadi T up daripada bawah naik ke atas. And the second one, the D here is more towards the vertical. Okay, the vertical height. Tu yang atas. Sekejap Saya lukis. Okay, first one. Okay. First equation. V2 equals to V1 plus apa? 80 Is it? Betul tak? Okay. This talk about this portion. Okay, ni. Number 2, we have D equals to V1 square plus 2 AD. Is it? Silap. Bukan AD.
So yang ni yang last
week.
last week.
Last 2 week.
Class kan?
Last sebelum tu, betul tak?
Betul.
Kita recap.
So nak recap balik
Pasal kita kan hari tu saya janji nak tengok soalan berkenaan projectile. So soalan berkenaan projectile, kita akan guna equation ni. Tapi dia tak bagi tahu equation mana kita nak guna. Okay, jadi yang kedua, D equals to V1T plus half AT square. Ini, most of the time, this D referring to this, vertical. Okay, lepas tu kita ada yang ketiga, V2 square equals to V1 square plus 2AD. And this D is for this one, horizontal. Horizontal case, vertical case, and this one is the velocity and time. Okay. Jap. Saya cakap juga. Dah record belum? Okay. Alright. Ini penggunaan dia. So now let's take a look at some of the example. We start with the most simple one. Okay. Alright. We have a case of tennis player hitting a ball, and this ball travel horizontally, ground stroke horizontal. Maksudnya dia travel tegak lah. Okay, travel in a very very significant straight line. Okay. Lift the racket horizontally, ground stroke, with a speed. Let's say this ball had a speed of 22 meter per second. If the ball is, we call it as an air ball for 0.7 second before it start to fall down. So the question is, how much is this? Ni soalan tak ada kaitan sangat dengan projectile. Ini straight line, linear. Okay. So the question is, how far the ball travel in 0.7 second if the velocity or the speed of the ball at that particular instant of contact is 22 meter per second. Berapa jauh bola ni bergerak? Ini soalan direct. The velocity is 22 meter per second. Distance covered in 0.7 second. So kalau 1 saat 22 meter, 0.7 saat berapa meter? Itu je soalan ni. How far does the ball travel in 0.7 second? Jadi distance equal to speed over time. Benda mudah. 22 over 0.7. Adakah begitu? Okay. Berapa?
15 point. Berapa tak? Jap.
15.4.
Ya, betul tu. 15.4.
Ni soalan senang. Okay, this is just a simple equation. Okay, cuma dia nak masukkan projectile bila dia sebut bola jatuh je. So, sometimes read the question carefully. Okay, sometimes it's just a trick question. Okay, soalan nombor 2. How high above? Okay, how high? Gila lah, tanya high ni payah How high above? Okay, right. Sebelum kita masuk how high above, kita tengok balik equation. Okay, let's talk about this equation again. When we talk about D, kita ada dua equation yang ada D. 1, 2. Okay, equation number 2, equation number 3. So this D representing distance. Okay, it is representing distance. Okay. So next from here, before we choose which one to be used, okay, kita kena tengok information. We need to read through the information, and then only we can move on. Okay, such as this equation, this question, you're going to get quite confused here. Okay, the question is simple. We have a person playing a trampoline. Whee! Okay, so soalan dia, a trampolinist spring vertically, naik ke atas, okay, spring vertically upward with an initial speed. So speed here is 9.2 meter per second. How high above the trampoline will the trampolinist go? The question is ni. Dia sampai dekat apex. How high? So the information that we have here is the starting V, okay, V1, 9.2 meter per second. Okay, and this is a vertical equation. Tak ada pun melibatkan melibatkan sign. There are no horizontal here. Okay, number 2, we try to find D. Number 3 yang kita ada, ni benda kat atas ni. Always remember this one. We have V2 equals to 0. And number 4, the always forgotten one. A, negative 9.81 meter per second. Which equation can we use to solve that? Equation number 2 ke? Equation number 3? 2 ke? 3? Yang mana yang kita?
2.
2. Okay. Do we miss something dekat sini yang kita tak ada? Ada tak benda yang kita tak ada kat sini? Berbanding kat sini. Ada satu benda. There are difference. Tengok saya tunjuk balik. We have V1, we have V2, we don't know D, we have A. Do we have T?
No.
No. Jadi, equation number 2 boleh pakai tak?
Tak.
Tak. Tu cara untuk kita pilih equation. Although most of the time this D being used to show the the vertical aspect, since equation nombor 2 ni cerita tentang the down phase. And this D is how high. However, bila kita masukkan V1T dekat sini, V1 dia kosong. And we don't have the T. Compared to D yang ketiga, we have all the information, which makes it much easier for you to calculate. So kita akan guna equation ketiga. V2 square equals to V1 square plus 2AD. Substitute je lah. V2 square kosong. V1 square 9.2 plus 2A negative 9.81 D. Dapatlah jawapan dia. Berapa tu jawapan dia tu? Square. Ni, square. Lupa apa. Berapa kita dapat? Berapakah 9.2 square? How much is 9.2 square? 80.
Negative 10.42.
Negative 10.42. Dapat kat mana? Dapat kat mana negative 10?
Sekejap.
9.2 kita dapat 84.64. So the first ni benda ni kita pindah dulu sebelah. So kita akan dapat negative 84.64 equals to ni 9.81 kali dengan 2. 9.81 times 2, we have 19.62. Negative 19.62D. Jadi D equals to negative 84.64 divide with negative 19.62. Itulah jawapan dia. 4.64 bahagi 19.62. 4.31. Mana datang 10
Salah. Saya salah kira yang saya tak bawa ke kiri.
Oh, alright. Semua sini je. Kalau semua sini je pun, supposedly you're going to have quite a similar outcome kan? Tak
Sebab saya letak 92 bukan 9.2.
Cuma kamu akan hilang positif lah kat sini, negatif. You don't transfer, dia jadi positif. Dapat 10 Oh, 4 kali ganda tinggi dia tu bang. Cuba bayangkan kalau 10 meter punya trampolin, bila dah sampai atas, nak turun balik bawah. Layak boh. Okay, boleh simple kan? Let's go to the third one. Yang ketiga ni, okay, yang ketiga ni ada banyak step. Apa? We go slow. Boleh? Can we move?
Boleh sir.
Ni main rugby ke apa ni Ke main baseball? Baseball near sideline. Down the near sideline. Okay, kita ada a player. We have a player. Player from Dallas. This player carrying the ball straight down. So he has a ball and he carry straight down the near sideline. Maksudnya dia berlari lah. Near sideline with a velocity of 8 meter per second, crosses the 50-yard line at the same time that the last Buffalo Bill who can possibly hope. Okay, dia dah sampai satu area 50-yard line. Okay, and then at the same time that the last Buffalo Bill, so kita akan ada satu lagi orang somewhere around here lah. This fella try to catch that one. Okay, try to catch the Dallas. Yang ni daripada nama Bill. Okay. Who can possibly hope to catch him? Start running from the 50-yard line at point that is from the near sideline. Okay, macam ni. Dia bukan kat sini. Alright. So dia berlari dekat near sideline with a velocity of 8 meter per second, cross the 50-yard line at the same time. So Mamat ni bukan macam ni. Mamat ni dah lepas 50 meter yard line. Dia sedang berlari dekat near sideline. At the same time, when this Mamat just move over the 50-yard line, okay, kita ada seorang lagi dekat sini. Try to have something like this. Bill. Okay, 13.7 meter from the near sideline. So dia dengan this area dengan dia is 13.7 meter. Okay, 13.7 from the near sideline. What must the Bill velocity be? Okay, soalan dia, how about velocity of Bill if he is to catch the cowboy just short of the goal line? Okay, so dua-dua nak ke sini. Goal. Okay, dua-dua nak pergi goal. So okay, so we have Dallas running at 8 meter per second, and at the same time there are somebody else running towards Dallas, and the distance is 13.7 meter. Soalan dia, um, directly for the corner of the field where the sideline meets the end zone. Okay, kejap. Saya tengah bayangkan gambar. Dia tak ada gambar kat sini. Okay, dia tak ada gambar dekat sini, but we actually calculate the distance of Bill. Bill must run if he hits directly to the corner of the field where the sideline. Okay, so maksudnya something like this. Okay, we have side. Ni sukan apa ni? Rugby eh? Sukan main rugby? Do you have sideline? Cool. Okay. And then we have somebody running like this. Okay. We have Dallas here running through the sideline with a velocity of 8 meter per second. And we have Bill here, which is 13.7 meter from the near sideline. From the near sideline. Okay, not that one. This one. 13.7 meter. Running at unknown velocity to here. So, Bill's intention is to catch Dallas before he met the goal line. Okay, sebelum dia jumpa goal line tu, Bill cuba untuk catch. So, dia target here. Means this is a concept of Theorem Pythagoras. Okay, segitiga. Okay, next one. What we have here, Dallas Cowboy carrying the ball straight down the near sideline with a velocity of 8, crosses the 50-yard line. Means at this point, the distance between this place, between Dallas and the goalpost is 50 yard. Kita ada dua kiraan berbeza, 1 yard, 1 meter. Okay. So the question is, what must be Bill velocity in order for Bill to catch Dallas here? Faham tak? Dapat tangkap? Kena saya ulang sekali. Halo? Halo?
Sekali lagi je.
Sekali lagi Okay. So kita ambil daripada tengah, daripada midline. Alright. So macam ni okay. So this is the goal line. So the question, the information we have is, kita ada satu mamat daripada Dallas running dekat sideline. So this is sideline lah, sideline PU. Running at the sideline through to the goal. Okay, to the goal line. And his running velocity dia ialah 8 meter per second. Okay, and then at the same time we have another player, opponent player. We name it as Bill. And the distance between Bill and Dallas. Okay, this is Dallas. The distance between Bill and Dallas is 13.7 meter. Jadi dia takkanlah lari ke atas kan, since Dallas lari ke depan, so dia akan lari in diagonal. So he tried to catch Dallas before goal. Okay, now second information we have is this fella is 13.7 meter from the sideline. So dia dengan sideline 13.7 meter, and the distance between Dallas to the goal is 50 yard. 50 ela. 50 ela. 50 yard line. So the question is, what must Bill velocity, how fast Bill need to run in order to catch Dallas here? Tu soalan dia. berapa laju dia kena lari in order to catch Dallas. So to know that, first and foremost, we need to know what is the distance here. How far is the distance need to be covered by Bill? Berapa jaraknya? Berapa jaraknya? Berapakah? Kita kena tukar ayat ni jadi meter. Berapa dapat?
47.52 meter.
47.
0.52.
Kamu pasti ke dia punya yard tu 47?
Tahu? Saya Google je, sir.
Kejap. Saya kira itu tak sama. Sekejap Google. Pakai converter Okay. Yard dia kalau ikutkan yard ni kita kena buat dua proses. First we change yard to feet. So kita ada 50 yard. Satu yard 3 feet. Kita ada 150 kaki. Itu pertama. Okay, this is the distance ni. So ni sama dengan 150 kaki. And then for kaki pula, to change to meter, we need to satu kaki sama dengan 0.308 304.305. Jadi kita ada 150 kaki, we multiply 45.75. Sama lah kan?
Lebih kurang je, sir.
Kamu dapat apa?
72.
45.72. Okay, tak apa. It's okay. So kita gunalah yang kamu punya. It's okay, sama. 45.72. But that is the way daripada yard pergi feet, feet pergi meter. Kalau kamu tak ada converter, kalau tak ada converter sangat, ingat ni je. 1 yard 3 feet. 1 feet 0.3, cukup dah. 0.3 meter. Tak payahlah 0.4 apa tu. Okay, so now kita dah ada dua. Kita dah ada 45.72 meter, 13.7 meter. Now we need to find a resultant dia berapa. So R square equals to A square plus B square. R equals to A square plus B square square root. A berapa? 45.72 campur dengan 13.7 square root. Dapatlah kita R. Berapa kita punya R? Berapa R? 45.72 square. Weh. Oh, sorry. Tak masuk tip puluhan bawah. 2090. Nampak jauh dia lagi ni. 0.32.
40. Macam mana?
40 berapa dapat? 13.
47.73.
Okey. 187.7 sekejap Campur 187.7. And then kita square root kan. 209032 187.7. 227 mana saya punya square root? Ni dia. 47.72 atau 47.73. 0.73 meter. Okay, so now we have R. Tambah sikit. Jadi sini kita ada 47.73 meter. Okay, belum selesai lagi. Okay, now we have distance covered. One need to run 45.72, another one need to run 47.73. So dia kena lagi laju. Kalau soalan dia berapa laju tadi, kita basically dah boleh bagi jawapan kat sini. Kena lagi laju daripada 8 lah. Because the distance is longer. Okay, tapi kita kena prove kan. Okay, next you have the distance. So now is about the time taken. Berapa lama masa si Dallas ambil untuk sampai end line. So to calculate time, kita akan gunakan distance divide by speed yang ada. Okay, D over S. formula asal dia yang ni. D. Distance equals to apa tu? Ni T, S. Apa ni? Banyak sangat. Sekejap. Salah tulis. Okay, we try to have the time. Time here equals to distance by velocity. Okay. Ataupun speed dekat sini. Oh tu. Saya mix up. Tadi ingat speed tu masa speed. Okay. Distance by speed. Okay, kita kira kan T untuk Dallas and T untuk Bill. Okay, so Dallas we have 45.72 divide with 8.
8 meter.
Berapa? Berapa saat?
5.7 saat.
5.7 saat. Means that Dallas will be at the end line in 5.7 second. Okay, soalan dia tadi. What must the Bill velocity? Jadi, berapa
47.73 tu bagi dengan 5.7 saat.
berapa?
So dapatlah
45.
47.73
Okay, divide by?
divide by 5.7 saat tu,
Yes.
baru dapat Bill punya
Velocity.
kelajuan ni.
Betul. Bagi dengan masa ni 5.7 saat. In other words, if Bill try to reach at the same time, that's why we use the same timestamp. Dia akan ambil masa 5.7 to reach here. So if Bill try to catch Dallas, he need to run with the same time. The difference is only towards dia punya velocity, which is 47.73 bagi dengan 5.7. You end up dengan 8 point berapa
8.35 meter per second.
meter per second. So this need to be the velocity of Bill. And only by having this velocity, lebih laju daripada Dallas tadi, he can catch Dallas before goal line. Dia ada banyak step. Okay. Itu adalah soalan ketiga. Let's try another one. Okay. Bola sepak. We have a soccer ball kick from the playing field. Okay, kita ada satu bola. Bola ini disepak. Poing. With an angle of 45 degree. Okay, if the ball is in the air for 3 seconds. Okay, katalah bola tu naik sebelum dia turun. Here. So, the up portion, take T up equals to 3 seconds. Okay. The question is, how high? T. Berapa lama boh? Berapa lama? Berapa tinggi dia pergi? Kita nak pakai D mana ni? Which D are we going to use? Tu dia. D mana kita nak pakai? Mana satu D? Kita ada T. T je kita ada, betul kan? We only have T. Jadi, the D that can be used with only T.
Yang first
Yang kedua. Yang first tak ada T. Tak ada D. Kita nak cari D. We try to find how high it goes. So, how high it goes is the distance, vertical distance. So, we have two equation for distance. But the equation, the problem only give you time. Jadi, yang ni tak ada time. Don't bother to use this one. We use the second one. Okay. So, when we use the second one tadi, rules dia kita guna untuk yang mana? Up portion ke down portion? Yang kedua. It is mostly used for down kan? Betul tak?
betul sir.
Okay. And then mana tadi kita punya down? Ni. And then okay, kita ada macam ni. Letak 45 bola. And then it said that T up dia 3. So by knowing T up 3, T down ni kamu tahu tak berapa? Berapa sangat?
3.
3. Why?
T up equal to T down.
Equals to T down if Nampak? Dia bagi tahu dah 45. Maksudnya, this one start and end at the same height. Siapa kawan kamu baru masuk? Okay, at the same height. Tu maklumat yang kita ada. And due to that, we try to find out D. So, kita ada dua je equation ada D. Satu equation nombor 2, which is this one. V1T plus half AT square. Okay, V1T plus half AT square. And lagi satu D, kita ada dekat V2 square equals to V1 square plus 2AD. Ada dua je. And the only formation we have is T. Pakai yang ni. Jangan ambil ini. Cari masalah nama dia. Alright. So, this equation talks about the down part. The T is equal. Down part, V1 dia dekat mana? Velocity initial dia dekat mana? Is it at the bottom or is it at the top?
Top.
Dia akan ada dekat top. Velocity untuk equation number 2, V1 dia dekat top because this one talks about the down portion. Kalau yang pertama tu V1 equals to V2 equals to V1 plus half AT remember dal V2 equals to apa dia? V1 plus AT. V1 plus AT. Yang ini cerita up portion. Jadi V1 at the bottom, V2 at top. Kenapa kita kena tahu which one serve which one? Because when V1 at the top, we can substitute V1 with 0. So automatically kalau V1 0, D equals to V1T plus half AT square. V1 0, automatically yang ni kita dah boleh potong. Jadi D equals to half AT square. Dah boleh jawab. Half negative 9.81 3 square. Dapatlah jawapan ni. D dia berapa tinggi boleh pergi? Berapa tinggi dia boleh pergi?
11 meter.
11 meter. Kenapa negatif dia hilang? Kenapa negatif dia hilang? So ini jawapan logik je. Rasa macam ada sedikit kekeliruan ni. Sekejap Cuba fikir kenapa negatif dia hilang?
Sebab kena times kot.
Sebab kena times? Tak. Sebab tadi kan dia nak distance vertical. So bila distance vertical ke atas, we just neglect the negative because we already know which direction it goes. Cuma kalau kata jawapan kamu ambil betul-betul tadi, dia akan jadi dia akan jadi negatif lah, negatif 11. Tapi bila negatif 11 menunjukkan distance tu ke bawah, itu je. Okay, we have problem here. Please take a good look here. 3 ni. Okay, so soalan tadi dia menyatakan soccer ball is kicked from the playing field at 45. Okay, we have 45 here. If the ball is in the air for 3 seconds, it does not sit going up or going down. Meaning, this 3 seconds is T total. Sama dengan 3 saat. So, if 3 total is 3 seconds, T down sama dengan berapa saat?
3 seconds.
1.5. T total, ingat balik yang kita belajar minggu sudah sama dengan T up plus T down. So kalau T total 3, T up and T down is equal in term of numbers. It is 3/2. 1.5 saat. So when you substitute this in here, you're going to get 11. Itu dia. Dia kena tengok equation tu. Kadang-kadang equation mengelirukan. Okay. Ni apa ni? Bola lagi. Alright. Okay, boleh. Can we move on to the next one?
Boleh sir.
Kita tak nak pergi jauh dari sini. Okay. Okay, now the case is ball is being kicked horizontal distance. Okay, again kita ada projectile. Okay, so distance here is 45.8 meter. The ball being kicked and it reached this distance. Okay, if the ball reached a maximum height of 24.2, maximum height it can goes is 24.2 meter. Okay. With a flight time of 4.4 second. Okay. Maksudnya T total dia is 4.4 second. Means down portion 2.2, up portion 2.2 second. This is the time. T up, T down. This is vertical height. This is horizontal. Okay. 4.4 second. Okay, soalan dia. Was the ball being kicked at a projection angle less than, greater than, or equals to? Soalan dia, angle kick ni, this angle, theta dia ni, is it 45 or is it more than 45 or is it less than 45? Kita nak predict angle dia. Okay. So this one, kita nak pakai yang mana? Macam mana kita nak mula ni? Macam mana? Macam mana? Okay. Kalau benda macam ni menyusahkan kepala, always start with this one. Okay, pasal kita perlukan figures in order to prove. Okay, kita perlukan figures untuk prove. Right. So, if we assume theta here is 45 degree. Okay, if we assume theta here is 45 degree. Okay, because ingat balik apa yang kita buat dulu. R equals to V cos theta T. Okay, ataupun kat sini sebenarnya V cos theta ni ialah velocity lah kali dengan time. Okay, now if we assume theta is 45, the figures or the value for sin theta will be equals to cos theta. Okay, kat sini. Jadi dengan kata lain, velocity horizontal and velocity vertical if theta is 45 adalah sama. Adalah sama. Pasal bila kita nak cerita velocity ni kan, kejap lagi kita kena ada V cos theta dengan V sin theta kan. So, we assume V cos theta dengan V sin theta adalah sama. And in order to do that, we are going to choose 45. Because 45 yield the answer of 1. Sin 2 theta. 1. Okay. Next. Apa lagi kita ada? Kita ada, let's find out dua komponen. Kita kena cari horizontal komponen dia dengan vertical komponen dia. Okay, we are going to find out for the first one. And then we can prove whether horizontal dia sama dengan ini, vertical dia sama dengan ini, ataupun tidak. Maksudnya kalau tak sama, the angle is not going to be 45 lah. Okay. So we go to the first one, horizontal component. In order to find horizontal component, ni dia. R equals to V kali dengan T. Okay. R equals to V kali dengan T. Jadi, kita dah ada R. 45.8. V dia berapa? V dia berapa? V dia berapa? V dia berapa? Berapa V dia?
Sejak.
V, masa dia ada tak? Kali dengan 4.4 total time. Okay, total time. Because this equation T ni ialah T total. Tu dapatlah V kat situ. 4.4 V sama dengan 45.8. So V sama dengan 45.8 bahagi 4.4. Ni 10 something. 45 bagi 4 ni.
10.41.
Yep. 10.41 meter per second horizontally. Okay, this is horizontally. Kita tengok vertically pula. Okay, kita nak tengok berapa jauh dia boleh pergi. Okay, kita nak tengok berapa tinggi dia boleh pergi. Kita nak tengok berapa tinggi dia boleh pergi. Alright. Untuk tinggi, kita ada dua tadi kan. We have D equals to V1T plus half AT square. Dengan kita ada V2 square equals to V1 square plus 2AD. Sekarang kita nak D. Equation mana kita nak pakai?
Cos.
Equation 2 ke equation 3? Yang mana lagi mudah agak-agak nak pakai kat sini? We are going to use this one. Pasal information ni semua kita dah ada dah. Tak payah sakit kepala. Paling senang pasal V2 dia. Okay. So V2 here is here. Tak ada. Kosong. V1 we take here. Okay. So now, why actually we choose equation number 3 and not equation number 2? Because from the first place, this velocity is being calculated by using the whole equation, the whole range equation, which is horizontal. And this is a recommendation to be used for horizontal case. Macam tu cara dia. Okay. V1, masuk je lah. 0.41. We have square. Don't forget that. Plus 2. Negative 9.81. And then D. Okay. 10.4. 5.5. Betul. Negatif 108.37 equals to 9.81 kali 2. Ni kita dah buat tadi ni. F 19.62D. So D will be 108.37 19.62. Ada saya tertinggal apa-apa? Nampak macam ada tertinggal ni. 19.62 5.52 meter. 2 meter. Okay. This is what we have found. We found that based on this velocity of cake, the ball can only travel vertically 5.52. Tapi, this information said that the ball did travel 24.2. Jadi maksudnya sekarang, angle dia 45 bukanlah. Is it going to be more than 45 or less than 45? In order to get this height. Kena lebih 45 ke kurang 45? Lebih lah. Tu lah jawapan dia. Soalan dia pun dia nak tahu whether the angle is larger than 45, lower than 45 or 45. So we have proof based on 45, it cannot go to 24.2, it just go up until 5.52. So in order to get for 24.2, you need to have more than 45 degree. Yang maksudnya sekarang, okay, Kenapa orang akan bertanya, kenapa kita tak guna yang ini? Ada T ni, kenapa tak guna? We have the T. Yes, we have total T. But based on the analysis up until now, we can prove that the trajectory is not a smooth trajectory. Dia bukan trajectory yang macam ni. Panjang pula. Dia bukannya trajectory yang kita bayangkan begini. But it may be something like this, where we have difference between up and down. Yet, the total time taken for this projection is 4.4 second. Ni reason dia kenapa kadang-kadang kita tengok kenapa tak pakai nombor 2 tu kan paling mudah. Satu, we choose equation based on function. So the question is to find out how high. But most of the equation and also information is about range. Jadi ni horizontal. So horizontal equation nombor 3. Okay, so recap a bit. This is the first equation. V2 equals to V1 plus AT. Talks about T up portion. Equation number 2, D equals to V1T plus half AT squared. Talks about down portion. And V3, V2 square equals to V1 square plus 2AD. This one talks about horizontal component. Means relation between horizontal. The true equation for horizontal component is R equals to V cos theta T. Okay, V cos theta ni V sebenarnya in horizontal setting. But when we include angle, dia akan jadi V cos theta. And this T is T total or T up plus T down. This is equation of constant acceleration. So if you face any problem regarding projectile, this is the equation that you need to have, that you need to remember. Okay, so that will serve as the end of our class. Do you have any question before we end the class?